3 coins are tossed, how many outcomes are possible? Let's have a look at the situation. For the first coin, you could get heads or tails. For the second coin, you could get heads if you got heads on the first one, or tails if you got heads on the first one. Or if you got tails on the first one, you could still get heads or tails. For the third coin, same thing, you get heads or tails for each previous outcome. Your outcomes, you can get heads on the first, heads on the second, heads on the third, or you get heads, heads, tails, or heads, tails, heads, or heads, tails, tails, or tails, heads, heads, or tails, heads, tails, or tails, tails, heads, or tails, tails, tails. Notice that's 8 different outcomes. So 2 outcomes for the first, 2 outcomes for the second, 2 outcomes for the third step. The shortcut is we can multiply them. For each step on the first one, you have 2 steps that branch off it. And for each step on the second one, you have 2 steps that branch off of that. So it's 2 times 2 times 2. 8. This is what we call the basic counting principle. If an experiment has 3 steps, if the first step can be done in, let's say, 2 ways, and the second step can be done in 5 ways, and the third step can be done in 3 ways, then the experiment can be carried out in a total number of 2 times 5 times 3 ways, which is 30 different ways. Okay, in this case, our first step has 2 different ways, heads or tails. Second step, 2 different ways, heads or tails. Third step, 2 ways, heads or tails. So it's 2 times 2 times 2, 8 different ways that the experiment can be carried out, or 8 different outcomes. That's the basic counting principle. You multiply the number of ways that each step can be done. Let's look at another example. 2 dice are rolled. How many outcomes are possible? All right, for the first step, you have 6 different ways that you can get a number. You could roll a 1, or a 2, or a 3, or a 5, or a 6. For the second die, there's 6 ways. It's 6 times 6, 36 different ways. Let's look at another example. A die is rolled and then a spinner with 5 foods is spun. How many different outcomes are possible? For the first step, there are 6 outcomes. For the second step, there are 5. So 6 times 5, 30. An opaque paper bag, that's a paper bag you can't see through, contains 9 balls numbered 1 to 9. 3 balls are drawn with replacement, so you're putting the balls back in each time. How many outcomes are possible? You're putting them back in each time. There's 9 possible outcomes for the first drawing. For the second, because you're putting the ball back, you still have 9. And for the third, you still have 9. It's going to be 9 times 9 times 9, which is 729. Basic counting principle, multiply the number of ways that each step can be done. Here's another example. There are 5 trains between Quebec and Trois-Rivières, 4 trains between Trois-Rivières and Montreal, 6 trains between Montreal and Ottawa. How many different combinations of trains can you take to get from Quebec to Ottawa? There are 5 ways that you can take a train from Quebec to Trois-Rivières. There are 4 ways you can take a train from Trois-Rivières to Montreal, and there are 6 ways from Montreal to Ottawa. It's going to be 5 times 4 times 6. 5 times 4 is 20, times 6 is 120. Multiply the number of ways that each step can be done. That gives us 120 different ways. Here's another example. A spinner with 7 letters is spun, and then another spinner with 6 names is spun. How many possible outcomes are there? 7 times 6, 42. Multiply the number of ways that each step can be done. Well, 7 for the first spinner, 6 for the second spinner. That's 42 different ways. A coin is flipped and then 2 dice are rolled. How many possible outcomes are there? For the first step, there are 2 different ways that you can get a result. For the second, there are 6 different ways. The die has 6 sides. You have 6 numbers to come up. For the third step, 6. It's 2 times 6 times 6, which is 72. That is it for the basic counting principle, and that's pretty much it for level number 1. Have a good day.